Hello everyone, this is Dr. N.Senthil Madasamy, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session. In this session, topic to be covered is public clouds and service offerings and Google App Engine under public cloud platforms for Unit 3 cloud platforms architecture. At the end of Unit 3, students will be able to explain design principles, architecture, and enabling technologies of cloud platform. At the end of this session, the students will be able to understand public clouds and service offerings and Google App Engine under public cloud platforms. Now we will see about public clouds and service offerings. Cloud services are demanded by computing and IT administrators, software vendors, and end users. This diagram introduces 5 levels of cloud players. At the top level, individual users and organizational users demand very different services. The application providers at the SaaS level serve mainly individual users. Most business organizations are serviced by IaaS and PaaS providers. The infrastructure services provide compute storage and communication resources to both applications and organizational users. The cloud environment is defined by PaaS and platform providers. Note that platform providers support both infrastructure services and organizational users directly. Cloud services rely on new instances in machine virtualization, SOA, grid infrastructure management, and power efficiency. Consumers purchase such services in the form of infrastructure as a service, platform as a service, or software as a service as described in previous sessions. Also, many cloud entrepreneurs are selling value-added utility services to massive number of users. The cloud industry leverages the growing demand by many enterprises and business users to outsource their computing and storage jobs to professional providers. The provider service charges are often much lower than the cost of users to replace their obsolete servers frequently. This table summarizes the profiles of 5 major cloud providers by 2010 standards. Amazon founded the IaaS business in supporting e-commerce and cloud applications by millions of customers simultaneously. The elasticity in the Amazon cloud comes from flexibility provided by hardware and software services. EC2 provides an environment for running virtual servers on demand. S3 provides unlimited online storage space. Both EC2 and S3 are supported in the AWS platform. Microsoft offers the Azure platform for cloud applications. It has also supported the .NET Service, Dynamic CRM, Hotmail, and SQL applications. Salesforce.com offers extensive software as a service applications for the online CRM applications using its force.com platforms. As table shows, all infrastructure as a service, platform as a service, and software as a service models allow the users to access services over internet, relying entirely on the infrastructures of the cloud service provider. These models are offered based on various SLAs between the providers and users. SLAs are more common in network services as they account for QoS characteristics of the network services. For cloud computing services, it is difficult to find a reasonable precedent of negotiating an SLA. In broader sense, the SLAs for cloud computing address service availability, data integrity, privacy, and security protection. Blank spaces in the table refer to unknown or underdeveloped features. Now we will see about Google App Engine. Google has the world's largest search engine facilities. The company has extensive experience in massive data processing that has led to new insights into data center design and novel programming models that scale to incredible sizes. The Google platform is based on its search engine expertise, but as discussed earlier with the MapReduce, This infrastructure is applicable to many other areas. Google has hundreds of data centers and has installed more than 460,000 servers worldwide. For example, 200 Google data centers are used at one time for a number of cloud applications. Data items are stored in text, images, and video and are replicated to tolerate faults or failures. Here we will discuss Google App Engine GAE, which offers a platform as a service platform supporting various cloud and web applications. Next we will discuss about Google Cloud Infrastructure, Google App Engine architecture, functional models of Google App Engine, Google App Engine applications. Now we will see about Google Cloud Infrastructure. Google has founded cloud development by leveraging the large number of data centers it operates. For example, Google founded cloud services in Gmail, Google Documents, and Google Earth, among other applications. These applications can support a large number of users simultaneously with high availability. Notable technology achievements include the Google File Systems, GFS, MapReduce, Bigtable, and SATP. In 2008, Google announced the Google App Engine web application platform, which is becoming a common platform for many small cloud service providers. This platform specializes in supporting scalable web applications. Google App Engine enables users to run their application on a large number of data centers associated with Google search engine operations. We will see about Google App Engine architecture. This diagram shows the major building blocks of Google Cloud Platform, which has been used to deliver the cloud services highlighted earlier. Google File System (GFS) is used for storing large amounts of data. MapReduce is for use in application program development. SAPI is used for distributed application log services. Bigtable offers a storage service for accessing structured data. Users can interact with Google application via web interface provided by each application. Third-party application providers can use Google App Engine to build cloud applications for providing services. The applications are run in data centers under tight management by Google engineers. Inside each data center, there are thousands of servers forming different clusters. Google is one of the larger cloud application providers, although its fundamental service program is private and outside people cannot use Google infrastructure to build their own service. The building blocks of Google Cloud Computing application include the Google File System for storing large amounts of data, the MapReduce programming framework for application developers, SAPI for distributed application log services, and Bigtable as a storage service for accessing structural or semi-structural data. With these building blocks, Google has built many cloud applications. This diagram shows the overall architecture of the Google Cloud infrastructure. A typical cluster configuration can run the Google File System, MapReduce jobs, and Bigtable servers for structured data. Extra services such as SAPI for distributed logs can also run in the clusters. Now we will see about functional models of Google App Engine. The Google App Engine platform comprises the following 5 major components. The Google App Engine is not an infrastructure platform, but rather an application development platform for users. We describe the component functionalities separately. Data store, which offers object-oriented, distributed, structured data storage services based on big table techniques. The data store secures data management operations. The application runtime environment, which offers a platform for scalable web programming and execution. It supports two development languages, Python and Java. Software Development Kit is used for local application development. The SDK allows users to execute test runs of local applications and upload application code. The administration console is used for easy management of user application development life cycles instead of for physical resource management. Google App Engine Web Service Infrastructure provides special interfaces to guarantee flexible use and management of storage and network resources by Google App Engine. Well-known Google App Engine applications include Google Search Engine, Google Talk, Google Earth, and Gmail. These applications can support large numbers of users simultaneously. Users can interact with Google applications via web interface provided by each application. Third-party application providers can use Google App Engine to build cloud applications for providing services. The applications are all run in the Google data centers. Inside each data center, there might be thousands of server nodes to form different clusters. Each cluster can run multi-purpose servers. Google App Engine supports many web applications. One is the storage service to store application-specific data in the Google infrastructure. The data can be persistently stored in the backend storage server while still providing the facility for queries, sorting, and even transactions similar to traditional database system. Google App Engine also provides Google-specific services such as Gmail account service, which is login service that is application can use Gmail account directly. This can eliminate the tedious work of building customized user management components in web applications. Thus, the web applications built on top of Google App Engine can use the APIs authenticating users and sending email using Google accounts. In the summary of the session, we learned public clouds and service offerings and Google App Engine under public cloud platforms. I hope you found this video is clear about the topic I lecture. Thank you and have a pleasant day.